Students, in lesson 2.9, we are going to work on problem-solving division. So our essential question is going to lead us to our purpose for learning, which we want to be able to do by the end of this lesson. So our essential question today is, how can the strategy draw a diagram help me solve a division problem? So we are going to unlock the problem real world and read about Sean and his family and their chartered fishing trip. Sean and his family chartered a fishing boat for the day. Sean caught a blue marlin and an amberjack. The weight of the blue marlin was 12 times as great as the weight of the amberjack. The combined weight of both fish was 273 pounds. How much did each fish weigh? So boys and girls, what I'm going to do here is I'm going to underline the weight of the blue marlin was 12 times as great as the weight of the amberjack, because right off the bat we know the blue marlin is a much larger fish. So what we're going to do is we're going to bump down to our graphic organizer, and we read the problem, and we need to pull from the problem what do we need to find. So what do I need to find? I need to find the weight of each fish. And the reason that I know that, boys and girls, is because it says how much should each fish weigh. That's what we don't know right now, so that's what we're trying to find out. So the next question here, boys and girls, is what information do I need to use? So I need to know that Sean caught a total of 273 pounds of fish, and the weight of the blue marlin was 12 times as great as the weight of the amberjack. And now our last question in this first part of our graphic organizer, boys and girls, is how will I use the information? So in our essential question, we talked about the strategy, draw a diagram, and that's the strategy that we're going to use today. So I can use the strategy, draw a diagram, and then divide. I can draw and use a bar model to write the division problem that helps me find the weight of each fish. So let's try that out. So now we are going to go on to the part where we solve the problem in our graphic organizer. So I will draw one box to show the weight of the amberjack, and then I will draw a bar of 12 boxes of the same size to show the weight of the blue marlin. And the reason why we're doing this, boys and girls, is because we know that the blue marlin is 12 times as great as one amberjack. I can divide the total weight of the two fish by the total number of boxes. Now, boys and girls, the total number of boxes here is 13 boxes because there are 12 boxes here for the blue marlin, and then there is one box for the amberjack. So we can notice that our divisor is 13 because there are 12 boxes here and one box here. Altogether, 13 boxes. So right here it says write the quotient in each box. We can't do that yet, so we're going to have to divide first. So let's do our division first. So boys and girls, here we see that we did 27 divided by 13 was 12, two groups. 2 times 13 is 27. 27 minus 26 is 1. We regroup and bring down the 3, and we have 13. 13 divided by 13 is 1. 1 times 13 is 13. We subtract and we get 0. So we know that our quotient, boys and girls, is 21. Now, according to these directions here, we have to write the quotient in each box. So what I'm going to do is I'm going to fill in 21 in each of these boxes. So right now, boys and girls, if we use our graphic organizer, which is our diagram, we can see that the amberjack weighed 21 pounds. So the amberjack weighed 21 pounds. We're going to fill that information. Now, our second step here, it said to multiply it by 12 to find the weight of the blue marlin. And notice a strategy that we've been using all chapter 2 is we multiply the quotient by the divisor. So when we look at this problem, boys and girls, really what we have going on here is 21 times 3 ones, and then 21 times 10 ones, or 110. So when we multiply this out, we get what, boys and girls? Let's multiply this out together. 21 times 3 is 63, and then we have 21 times 10 is 210. We add up these partial products, and we get So boys and girls, what I saw was that I made a little bit of a mistake here, but I want to go back to this statement, these two statements here to help us guide our understanding in our question. It says first we're going to write the quotient in each box, which we did, and then it says to multiply it by 12 to find the weight of the blue marlin. So our quotient here was 12, and we are going to multiply it by the weight of the blue marlin, which was 21. So first we have 12 times 1, and then we have 12 times 20 ones. So when we have 12 times 1, we get 12. And then when we have 12 times 20, we get 240. If we add up these partial products, we get 252, which is the weight of the blue marlin. Now, boys and girls, you might say, well, how can I check that this is correct? If you take the weight of the blue marlin and you add it to the weight of the amberjack, it should equal 273 pounds, which is the weight of both fish together combined. And we see that it in fact does. So now, boys and girls, we're going to try the same exact sort of problem, but we're going to have less information to fill in the blank, and we're going to write more statements on our own. So let's try another problem. Jason, Murray, Dana went fishing. Dana caught a red snapper, and Jason caught a tuna with the weight of 3 times as the weight of the red snapper. Murray caught a sailfish with a weight 12 times as great as the weight of a red snapper. If the combined weight of the 3 fish was 208 pounds, how much did the tuna weigh? So boys and girls, what we're concerned here with is what? What do I need to find? Well, I need to find the weight of the tuna. And the reason I know this, boys and girls, is because that is the last question that is asked in the problem. So next, I'm going to go on to the next part of our graphic organizer, which is what information do I need to use? So boys and girls, follow with me carefully here, and if you need to pause and replay this anytime, you can. I filled in this box a little bit before you, and then I'm going to read it to you. So it says, I need to use the information that the 3 fish weighed 208 pounds. The weight of the tuna was 3 times as the weight of the red snapper, and the weight of the sailfish was 12 times as great as the weight of the red snapper. So like I said, if you needed to pause this point and rewind this just to make sure you got all that information, that's totally okay. We're going to go on to our last question. How will I use the information? So boys and girls, what we're going to do here is we're going to say that I can draw the bar model to write the division problem and then divide. So let's do some problem solving. So boys and girls, I can draw the bar model to show the relationship between the weights of the 3 fish. I'm going to first draw one box for the weight of the red snapper. So why don't you do that one with me? Three boxes for the weight of the tuna. And 12 boxes for the weight of the sailfish. I can divide the total weight of the 3 fish by the total number of boxes. So we know that the total weight for the 3 fish was 208 pounds. And we know that if we count up all the boxes, we have 1 box, 3 boxes, and then we have 12 boxes. So the total amount of boxes that we have here, boys and girls, is 16 boxes. So we can use that information to divide by. That'll be our divisor. So let's do some division, boys and girls. So we have 20 divided by 16, and we have that one equal group. So 1 times 16 is 16. We subtract and we regroup. We have 10 minus 6 is 4. We regroup and we have 8. Now we have 48. 48 divided by 16 is 3. 3 times 16 is 48, boys and girls, and we subtract and we have no remainder. So we know that 13 is going to be the quantity that we're going to fill into all the boxes. So what we can do is we can write that out first, and then we can figure out the weight of the tuna fish. So boys and girls, when you notice here, and I fill in all the boxes, the total weight of all the fishes together came up to be 208 pounds. And we see that we have 16 times 13, we get 208 pounds. So that's just showing us that strategy of multiplication to check our division answer. So if we notice here and we key in on our tuna fish, because that's what we're really concerned with, we see that the tuna fish, it has 3 boxes associated with. So boys and girls, I can multiply 13 by 3 to find the weight of the tuna fish. So when I multiply this out, 13 times 3, I get the answer of 39. So the tuna weighs 39 pounds, boys and girls. So it says, how can you check to see if your answer is correct? Well, a possible answer is that we can say we can add the weights of the fish all together and make sure that the sum equals the total weight. So what if we wanted to, we could add up all the weights. We could do 13 plus 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 13. But we know that we are in 5th grade, and we know that we can also do that by using multiplication to check. So we can take our 13 pounds multiplied by 16, and we could get the answer of 208 pounds. So we know that that would be another way we can check. So boys and girls, remember, if we wanted to check our answer, what we could say is, I can add the weights of the fish together, and then I can make sure that the sum equals the total weight. So these are all examples of how you can use a strategy, draw a diagram to help us solve a division problem. And in these last 2 particular problems, we use the actual bar model to help us solve our division problems.